Hi, very good day to everyone. Welcome to today's lecture. Today we are diving into one of the most comprehensive orthotic device used in clinical practice. We learned about ankle photosis. I remember it's last semester, last two semester during your BED class, and then now we will look at knee ankle photosis, which or we call it as Kafo, Kafo. Okay, so this device play an essential role in management of the individuals that require structural support, and then motion assistance or restriction, and also realignment of the lower limb lah. So we will walk through this design, its design, how is the fabrication technique, and also the clinical decision involved in prescribing KAFO. Alright, so our focus today, we will be fivefold. First, we will review the relevant anatomy of biomechanics that form the foundation for KAFO application. And secondly, we will identify when it is appropriate to use Kafo and when it's not. Third one, we will break down the step-by-step process on fabricating KAFO. Then fourth, we will examine the components that make up this device and how they each serve the user. And finally, we will end with important clinical consideration during fitting and follow-up, ensuring optimal performance and user compliance. Okay. I share with you in the spectrum the guideline from ICRC, and also the checklist during casting procedure. Can you please check in spectrum, and please bring it tomorrow so you can use it during the casting process. Okay. Right. Okay, now introduction to KAFO. So a KAFO, knee ankle foot orthosis, is a long leg orthosis that span the knee, ankle and foot, and is typically prescribed when patient lacks sufficient muscular controls to stabilize the joint during walking, during the gait lah. And it provide alignment, control motion. It reduce energy expenditure during walking, because people with muscular problem, usually they need to use more of their energy to walk, and can even help in correcting or preventing deformities. Okay, imagine a patient with post-polio syndrome. You can Google what is post-polio syndrome, who cannot stabilize the knee. Okay, this device can help them to achieve a more natural and safe gait. Okay, previously, before we have like the vaccine for polio, we use the use of KFO is very wide, and now very difficult to find this case nowadays. Okay, so indication for KFO are most commonly indicated in cases of severe muscle weaknesses, such as in lower motor neuron disease or spinal cord injuries. They are also prescribed for conditions like genu recurvatum, which is a knee hyperextension, where the knee buckle backward, or in patient recovering from orthopedic surgery that require long-term support, and also patient with poor proprioception or joint instability, especially in knee and ankle, which also benefit significantly. Okay, however, KAFO are not one size fits all solution. So if a patient has uncontrollable spasticity or fixed deformities, fitting them properly becomes very impossible. Yeah. So likewise, someone with skin ulcer or pressure-prone area might suffer further injury from prolonged KAFO use. So people with a skin problem, they cannot use KFO. It's very difficult for them. And it's also crucial to consider cognitive and functional capacity, and patients who are unable to independently manage their device may face significantly safety risks. Okay, now let's take a quick refresher on the structure involved. Okay, the femur connect to tibia, you know that. via knee joint, and primarily a hinge joint and to the fibula, and the foot via ankle joint. The subtalar joint beneath the ankle allows for side to side motion. Okay, please refer to lecture 1, I think. And muscle like quadricep and hamstring help to stabilize the knee, while gastrocnemius and tibialis anterior manage foot motion. Okay, and understanding mechanical versus anatomical alignment is the key when designing an orthosis that won't cause compensation or discomfort. Yeah. So we will look at several types of KAFO. There are 3 main categories: conventional Kafo, that use metal sidebar and leather for plastic cuff and durable, though it is a bit heavier. And then we have thermoplastic Kafo, which are the molded form of plastic and contour snugly to the limb, that we will do this week. And then offering this thermoplastic Kafo offer comfort and aesthetic. And also we have hybrid Kafo that combine the strength of metal with the precision and fit of plastic. Okay, so each design, the conventional, thermoplastic, and also hybrid Kafo, they serve a specific purpose depending on the patient physical needs and also goals. Alright, we will look at the detail for each of these type of Kafo. So conventional Kafo these are often in long-term users who need durability and adjustability. Okay, because we made it from it is made up of metal. Okay, the metal upright can be bent or altered during follow-up visit. They attach the shoes. The shoes is directly attached to the metal. Okay, and may incorporate drop locks or bail lock. You can Google what is drop lock and bail lock. I will share with you one video that show the difference between drop lock and bail lock at the knee. Okay, while they may lack the sleek appearance of newer design, they are invaluable for individuals with fluctuating edema or those who need breathable interfaces. Okay. Now, thermoplastic KAFO. These thermoplastic KAFO are formed of a model of the limb and offer a close total contact fit. Okay, they distribute the pressure more evenly and even generally lighter than the conventional Kafo. And these are ideal for younger patients or those needing more cosmetic and discreet support. And they are often used in neurological condition where the weight and comfort are the major concern here. And then we have the hybrid Kafo. So this type of Kafo provide both structure and also aesthetic, meaning it combine the conventional and thermoplastic it combine both structure and aesthetic appeal. So a patient with complex deformity requires strong correction on one side and more mobility on the other might benefit from this design. Okay, so for instance, a post-trauma case with asymmetric muscle loss may receive stability from metal upright on one side and comfort from the molded plastic shell on the other. Okay, now we will look at let's unpack the KFO. We look at the Kafo components. So Kafo components, the Kafo is made up of the thigh and calf shells that act as a primary load bearing structure. And then we have the knee joints, whether it is a simple hinge or more complex mechanism that control flexion and extension. And then we have ankle joints that are tailored to allow block motion as needed. Okay, the foot plate anchor the device, stabilizing the foot and enabling load transfer, and the strap and pad make the system wearable by improving comfort and security. Okay, now the knee joint mechanism. Okay, there are various mechanisms that we can employ actually depending on the need of the patient. A free motion joint does not just what it sounds like permit bending. and then drop lock are manually engaged and provide stability in full extension, and then bail lock are spring loaded mechanism that can be released with pressure from the back of the thigh lah. And offset joint align slightly behind the natural knee to prevent unwanted bending, and then polycentric joints allow for more a natural bend because they mimic the complex motion of the real knee. Okay, and then the ankle joint vary as well. Free motion joints allow natural gait but are only used when the patient has some muscle control. Dorsiflexion assist joints include spring to help lift the toes, useful in foot drop, and a limited motion joint restrict extreme position to protect the foot. And double action joints are customizable. You can add pins to limit the motion or springs to encourage it. Okay, the material used in KFO prefabrication. Okay, the choice of materials impact both performance and also comfort, but the comfort is more usually affected by the type of material used. Okay, aluminum is light and corrosion resistance, while stainless steel often offers more strength. So aluminum is like stainless steel provide more strength. Thermoplastic like polypropylene are ideal for molding, while carbon fiber is chosen with when strength to weight ratio is critical for those with heavy weight can use carbon fiber. And don't forget softer material like EVA or leather for strap and padding, and they ensure the device remains wearable. Okay, patient assessment and measurement before anything is built. A comprehensive assessment is a key. Clinician will examine. Okay, now this is a process of fabrication. Okay, so we have several process, which is the casting, a positive model creation. Yeah, before fabrication process we need to assess the patient first. Yeah, so this slide is related to the patient assessment and also measurement. Before anything is built, a comprehensive assessment is a key. Clinician will examine muscle strength, joint mobility, and skin condition. We will look at all these aspects, and gait analysis also will help to identify specific movement pattern that the KFO need to correct lah. And measurement include circumference and length at several anatomical landmark, plus identification of mechanical joint centers. Okay, now fabrication process. Okay, KFO fabrication is both art and science. It start with casting the patient limb to create a negative mold. I know by now you already know what is positive and negative mold. Then cast is then used to make positive model. The model is adjusted to correct deformities or relieve pressure, and the thermoplastic are then molded over it, and the final form is shaped, finished, and assembled with joints, strap, and padding. So this is like the summary of what you will do in the fabrication process. Okay, so casting, the first step. Casting is where it all begin. Okay, after donning a stockinette, okay, the anatomical landmark like a fibula, head, and malleoli, you can please refer to the checklist I provide in the spectrum, and then are marked lah. And then padding is placed over the bony area. Well, padding is actually optional. You can just mark the area, and after that, during the modification of the positive cast, you can add some plaster of Paris to modify it. Then either plaster or fiberglass bandage are wrapped. So in our lab, we will use a plaster of Paris bandage that we will use it to wrap securely around the limb, and then careful molding with the hand ensure anatomical accuracy, and the cast is peeled and removed when set. Okay, do not apply pressure when you are trying to do casting, because you can get better shape when you just mold it like natural. No force needed here. Okay, and then the second one is a positive model creation. How to make the positive cast. Just fill the plaster, fill the cast with the plaster slurry plaster to produce a positive model of the limb. Okay, you can check with the Encik Rahimi the ratio how to make the slurry plaster, and this replica become the form over which the final orthosis is shaped, and it must be accurate, durable, and free of air pockets. After hardening, the cast shell is stripped away. Okay, you make sure you get the long metal from Mr. Rahimi or Mr. Azwan before you fill in the plaster. Okay, and then we have modification. Next come one of the most skilled step, modifying the model. It is very confusing part, and the authorities will carve or build up area to redistribute pressure, correct alignment, or accommodate deformities. And key area include the patella, tibial crest, and thigh medial and lateral contours, making the mechanical joint center is crucial for joint placement. Okay, then we have thermoplastic molding. A sheet of thermoplastic, the plastic is heated in the oven until it is soft, and then the vacuum form over the modified model, and this step require precision, and the material must be evenly heated and confirmed before cooling. A poor mold here can lead to pressure source or misalignment later. Okay, and then we have trimming and finishing. Once the thermoplastic is cold, the rough orthosis is cut and shaped. Okay, opening are made for strap and locks, the opening in front, and then edges are rounded using grinder and hand tool to prevent any sharp of contact points, and every edge must be finished smoothly, especially around the popliteal area. So I will provide to you what is the nice what is the ideal trim line, and also the method to do this. And you know that every edge must has a very finish smooth finishing, I can say, and especially around the popliteal area, to provide comfort to the patient lah. If the popliteal area you give force, then other problem will happen. Okay, assembly. The final phase is assembly. Metal joints are attached to the mechanical center, and the straps are rivet or sewn in, and the pads are placed for comfort. And before delivery, a trial fitting is done, and this step allows for fine tuning to ensure Kafo fits well or not, and support effectively or not, and can be used comfortably during ambulation or not. Okay, once all of this complete and the patient has been trained on usage, we can move into follow-up and long-term monitoring to ensure the continued benefit. Okay, we will continue this lecture in the next video. I will give you what is the element that is needed in each of the process, so that you can use all this information while doing during the fabrication process. Okay, see you in the lab. Thank you for listening. Hope you have a good day. Thank you.